Hi everyone. Today we will solve this energy boosting geometry question. It is from Azerbaijan team selection test from 2025. It is given that there are two circles and the intersection points are D and E. And we have this line here, BC, that also contains D, and BD is equal to DC. Then we have A here, and it is the intersection points of the tangents from B and C to the respective circles. And we are asked to prove that dA times dE is equal to dC square. Or in other words, it can be dB times dC or dB square. Okay, after some time, we realize that we need just add some angles maybe or some edges to prove it. And I also do the same thing. Okay, first thing that came to my mind is just connecting BE and AC. Let's connect them.
5 minutes later.
Okay, let's say that this angle here, BED, is alpha. According to the rule that the angle between chord, here it is BD, and the tangent, BA, is equal to the same angle that subtends to that arc. Then it is alpha here. Let's do the same thing for the other angle, which is DEC. Then we will get that this angle here, which is BCA, is also beta. Now, please look at the ABC triangle. The A angle here is 180 degrees minus A plus B. And we realize that the opposite angles, E and A here, or we can say BEC and BAC, the sum of these two angles is 180. We found that BECA is a cyclic quadrilateral. It is so important. Actually, after I found that, I realized that we have one red diagonal here, which is BC. Then I just want to draw the other diagonal, which will be AE. Here, we realize that the angle CEA and CBA subtends to the same arc. Actually, it is the bigger circle here. The arc will be CA. That is why the angle ABC and AEC will be A, same angle. Now, look at here. D here is actually midpoint of the edge BC, and it means that ED is a median. On the other hand, we found that BED angle and the angle CEA is same, alpha. That is why we realize that EA is actually symmedian, particularly E symmedian in the triangle EBC. And there is this rule here of the symmedian. Let's call this circle omega, and the second intersection point with the omega and E symmedian will be A here. And according to the rule, we can say that this is also this AC median in the triangle BAC. That is why we can say that if this angle here is gamma, then this angle here is also gamma. Now we found that it is median, and now we will use the similarity of the triangles here. Okay, let's meticulously analyze what we have right now. We can easily see that the angle EBC and EAC is same, which is gamma. Here we see the similarities of the triangle EBD with the triangle we started from A angle, so here A angle is B, then B, here it is A and D. That is why now we can just use the property of the similarity of the triangles. Okay, let's use it. We can say that the ratios between the edges will be always same. It means that AB divided by BA is equal to BD divided by AD, and it is also equal to DE divided by DB. Now we will just cross multiply. Okay, let's see what can we multiply. I will use this part. No, I will use this part and this part. Okay, let's multiply. We will get that BD square is equal to AD times ED. In the question, we are required to find that DA times DA is equal to DC square. And we know that D is the midpoint of BC. It means that DB is equal to DC. So we can also say that this multiplication is also equal to DC square. Indeed, here we prove that this multiplication is equal to DC square.